Nothing travels faster than light. You've heard this your whole life. It is the golden rule of the universe, the cosmic speed limit, 299,792,458 meters per second. Einstein said it. Your teachers said it. They lied. Well, they didn't lie, but they left out the part that breaks your brain. Right now, in this room, I can make something travel faster than light. I can do it with a flick of my wrist. I can do it with a shadow. And here is the terrifying part. Darkness isn't just faster than light. Darkness is instant. While light has to crawl through the vacuum of space, fighting for every inch, darkness is already there, waiting. If the sun disappeared right now, we wouldn't know for 8 minutes. But the darkness at the source is immediate. So, how can a shadow break the laws of physics? How can nothing outrun the fastest thing in the universe? And if shadows can travel faster than light, why can't we use them to time travel? We need to talk about the speed of nothing. Let me show you. First, we need to agree on what light actually is. Imagine a photon, a tiny, jittery packet of energy. It shoots out of a light bulb. It travels through the air. It hits the wall. That trip takes time. Not much time, but time. If that wall is 1 meter away, the photon takes 3 nanoseconds. It's a physical object. It has luggage. It has to obey the speed limit of the universe. It has to crawl. Now, look at a shadow. Do this right now. Close your eyes and imagine a flashlight in your hand. You point it at a wall far, far away. You put your finger in front of the lens. Boom! A shadow appears on the wall. Now, flick your finger. The shadow moves. Simple, right? But here is the trap 99% of physics students fall into. If that wall is far enough away, say 5 miles away, and you flick your finger just 1 inch, the shadow on the wall sweeps across a massive distance in the same amount of time. It covers miles in a split second. Do the math, distance divided by time. That shadow just moved faster than the photon that created it. But wait, you say, that's cheating. A shadow isn't a thing. Wrong. In your brain, a shadow is a thing. You see it, you track it, it has edges, it moves. And this is where things get dangerous. Because if I can wiggle my finger here, and a shadow moves faster than light there, did I just send the signal faster than Einstein allows? If I did, I just broke causality. I just broke the timeline. To understand why I didn't, or why it looks like I did, we have to build a lighthouse, a very, very big lighthouse. Let's upgrade. No more flashlights. We need precision. Imagine you are holding a laser pointer, but not a cheap cat toy. This is a super laser. It shoots a beam that stays tight forever. Do this right now. Stand in your backyard and aim that laser at the moon. Yes, I know the moon is moving. Ignore that. Focus on the laser. You press the button. A red dot appears on the dusty lunar surface. Now, rotate your wrist, just a tiny twitch. You sweep the laser from the left edge of the moon to the right edge. You do this quickly. Snap, 1/10 of a second. Here is where the math gets scary. The moon is about 3,500 kilometers wide. If you sweep that dot across the face of the moon in 0.1 seconds, that dot just traveled at 35,000 kilometers per second. Fast, but not light speed. Light is 300,000 kilometers per second. We are safe. The universe is happy. But wait, let's zoom out, way out. Keep rotating your wrist at the exact same speed. But now, instead of the moon, aim that laser at a planet in the Andromeda galaxy. The beam travels out. It hits the planet. Because that planet is so far away, the arc you are drawing is massive. A tiny wiggle of your hand on Earth translates to a sweep of trillions of miles out there. If you flick your wrist in 1 second, that red dot on the distant planet sweeps across its surface faster than the speed of light. It's simple geometry. The farther away the wall, the faster the shadow, or the dot, moves. At a certain distance, that dot must break the light barrier. It has no choice. So, look at what you just did. You moved the red dot from point A to point B. You did it faster than a photon could get from point A to point B. This sounds like magic, but it's just geometry, and it leads to a terrifying question. If I have a friend on the left side of that planet and a friend on the right side, can I use this super fast dot to send a message between them? Can I use this faster than light swipe to tell the future? To answer that, we have to look at something sharper than a laser. We need a pair of scissors. Let's step back from the galaxies. Let's bring it down to your kitchen table. Grab a pair of scissors. Not a huge pair, just the normal kind. Open them wide. Look at the blades. Specifically, look at the exact point where the two blades cross. We call this the intersection point. When you close the scissors, that point moves. It travels from the hinge all the way out to the tip. Simple enough. You push the handles together, the point moves out. But watch closely. When the scissors are wide open, a small movement of the handles moves that intersection point just a little bit. It's slow, but as the blades get closer and closer to being shut, something weird happens. The angle gets smaller. The blades become almost parallel, and suddenly that intersection point shoots forward. It accelerates. The math tells us something insane here. As the angle between the blades approaches zero, right before they snap shut, the speed of that intersection point approaches infinity. Infinite speed. If the blades were long enough, say light years long, and you closed them at a normal speed here on Earth, that point where the blades cross would rip through the universe faster than light could ever hope to travel. Stop. Think about this. You are holding a physical object. You are closing it with your hands, and yet a mathematical point on that object is breaking the ultimate speed limit. How is this allowed? Einstein said nothing can travel faster than light. He was very specific about it. He wrote equations about it. So did we just disprove relativity with a pair of scissors? No, because here is the trick. We need to ask a very, very specific question. What is actually moving? Is an atom moving faster than light? No. The metal atoms in the blades are just moving up and down. They aren't shooting forward at light speed. Is energy moving faster than light? No. The energy you put into the handle is moving at the speed of sound through the metal. So what is moving? Nothing. Literally nothing. The intersection point is not a thing. It has no mass, it has no energy, it has no information. It is a geometric idea, a concept, a location where two things happen to be. And ideas are not bound by the speed of light. This is where your intuition fails. You see a dot moving. You see a cut moving. Your brain labels it as an object. But physics doesn't care about your labels. Physics cares about causality. And this brings us back to the shadow. Because a shadow is exactly like that intersection point. It's not a thing. It's a place where things aren't. Okay, we have to kill a sacred cow. We have to destroy the idea that a shadow is an object. You see a shadow move across the floor. You think, it moved. Stop. Let's slow time down, way down. When you block a light source, you are stopping photons. You are creating a region where light isn't. That region, the shadow, is not a thing that travels. It is a series of events. It is a sequence of no light here, then no light here, then no light here. Imagine a crowd doing the wave in a stadium. You see a wave travel around the stands. It looks like a physical object moving at 50 miles per hour. But is any person actually moving around the stadium at 50 miles per hour? No. Each person just stands up and sits down in their own seat. They don't move horizontally at all. The wave is a pattern. It is information. It is a collective behavior. It is not a physical object. A shadow is the same. When you move your hand across a light beam, you are simply changing which photons get blocked. The shadow doesn't move from point A to point B. Instead, at point A, the light turns off. Then a tiny bit later, at point B, the light turns off. Because the photons at point B have to travel farther than the photons at point A, or maybe shorter, the timing can be manipulated. If I set it up just right, I can make the darkness event at point B happen before the light from point A could possibly reach point B. I can make the shadow appear to sweep across a surface faster than light itself. But here is the catch. Here is the part that saves the universe. Can the shadow carry a message? Can I attach a letter to the shadow at point A and have it arrive at point B faster than light? No, because the shadow at point B is created by me, back at the source. It is not created by the shadow at point A. There is no causal link between the shadow at A and the shadow at B. They are independent events, both controlled by me. Think of a machine gun firing bullets at a wall. If I sweep the gun across the wall, the bullet holes appear in a line. I can make that line of holes appear faster than light. But the hole at point A didn't cause the hole at point B. The gun caused both. So while the pattern moves faster than light, the information, the cause, still travels from the gun to the wall at the speed of the bullet. This is the speed of ignorance. Let's play with fire. Let's imagine you are on Earth. You have your super laser. You aim it at the moon. Your friend Bob is standing on the left side of the moon. Your friend Alice is standing on the right side of the moon. You want to send a message from Bob to Alice. You sweep your laser from Bob to Alice. The red dot moves across the lunar surface at 2x the speed of light. Bob sees the dot. Then, 0.001 seconds later, Alice sees the dot. Since light takes about 0.01 seconds to cross the moon, the dot arrived at Alice before light from Bob could possibly reach her. This looks like faster-than-light communication. But wait, can Bob use the dot to send a message to Alice? Bob sees the dot. He wants to warn Alice. "The dot is coming," he shouts. He waves a flag. He turns on a flashlight. But his shout, his flag, his flashlight, they all travel at the speed of light, or sound if there was air. The dot arrives at Alice before Bob's warning, so Bob cannot influence the dot. He cannot change its color. He cannot make it blink. He cannot modulate it. The dot just passes him. It was created by you on Earth. The information came from Earth to Bob and from Earth to Alice. There is no information transfer between Bob and Alice. They both received a message from Earth, but they did not talk to each other. This is the key. Einstein's rule is, no information can travel faster than light. A shadow carries no information from one point to another in the shadow itself. The shadow at point A does not cause the shadow at point B. So, causality is safe. You can't kill your grandfather before you were born. But here is the twist. If a shadow is just the absence of light, and absence isn't a thing, then what about a wave? What about the thing that actually carries the energy? Because waves can do something very strange. They can cheat. If you have ever watched an ocean wave break on the beach, you have seen this. The break moves down the line of the wave faster than the water moves forward. This is called phase velocity. And yes, phase velocity can break the speed of light. Let's talk about a ghost. Physics has a name for it: phase velocity. This is where the universe plays a trick on you. It's a trick that allows waves to move faster than light, while energy stays slow. Imagine you are standing on the beach. You see a long ocean wave coming in at an angle. It hits the shore on the left. Then it breaks down the line, moving to the right. That break point, the white water, can travel down the beach incredibly fast. If the wave hits the beach at a very shallow angle, that break point can rip down the coastline at 100 miles per hour, even though the water itself is only moving at 10 miles per hour toward the shore. The break is not a physical object. It is a phase. It is a specific moment in the wave's cycle. Now apply this to light. Light is a wave. It has peaks and troughs. In certain materials, like plasma or weird crystals, the peaks of the light wave can actually travel faster than the speed of light in a vacuum. Wait, read that again. The peaks of the wave can travel faster than c. This is called superluminal phase velocity. So if I shine a laser through a tube of plasma, the individual crests of the light wave might be zooming through at 1.5 c or 2 c. Did we just break physics? Did we just send a signal faster than light? No, because here is the cruel joke. A pure wave, a perfect sine wave, carries no information. It is just an endless hum, up, down, forever. To send a signal to say hello or attack at dawn, you have to change the wave, you have to modulate it, you have to make a bump, a pulse, a start and a stop. This modulation, the actual packet of information, travels at the group velocity, and guess what? The group velocity is always slower than light. So while the phase, the ghost pattern, races ahead at impossible speeds, the actual message lags behind. It's like a long line of soldiers marching. The line can move sideways very fast, but each soldier is still marching forward at a normal pace. The pattern moves fast, the soldiers move slow. But what if we scale this up? What if the medium isn't plasma? What if the medium is the universe itself? Because right now, as you watch this video, darkness is winning the race on the biggest scale imaginable. Let's leave the beach. Let's leave the lab. Let's go to the edge of the visible universe. This is where physics gets terrifying. This is where speed limits stop making sense. Space is expanding. Right now, distant galaxies are moving away from us. They aren't moving through space. Space itself is stretching between us and them. And this expansion has a speed. If you go far enough away, beyond the Hubble horizon, galaxies are receding away from us faster than the speed of light. Wait, read that again. Galaxies are moving away from us faster than light? How is this allowed? Einstein said nothing can travel faster than light through space. But space itself? Space can do whatever it wants. Space can expand at 2c, or 10c, or a billion c. And because space is expanding faster than light can travel through it, the light from those distant galaxies will never reach us. It is trying. The photons are swimming upstream against a current that is moving faster than they can swim. They are losing the race. This means there are parts of the universe that are forever dark to us. We will never see them. We will never know they exist. Darkness is the default state of the cosmos. And that darkness is expanding. It is winning. Every second, more galaxies cross that horizon and disappear forever. The light they emit will never reach Earth. It will just fade into the red, stretch out, and die. So in a very real sense, darkness travels faster than light, because darkness is the absence of light. And if light can't keep up with the expansion of space, then darkness fills the gap instantly. The moment a galaxy crosses that horizon, its light is cut off. The darkness begins its journey to us, or rather, it is already here. Darkness doesn't need to travel, it just is. But there is one place where light fights back. There is one specific scenario where a particle can actually outrun light in a material. And when it does, it creates a sonic boom, a boom made of light. It's called Cherenkov radiation, and it is the ghostly blue glow of nuclear death. Let's talk about a shock wave. You know what a sonic boom is. A jet flies faster than the speed of sound. It breaks the sound barrier. Boom! The air can't get out of the way fast enough. The pressure builds up. It explodes outward in a cone. Now, imagine doing that with light. Imagine a particle, say an electron, moving faster than the speed of light inside a material. Wait, I said nothing can travel faster than light in a vacuum. But inside water, inside glass, inside a nuclear reactor, light slows down. In water, light only travels at about 75% of its maximum speed. It crawls. But an electron? An electron can still travel at 99.99% of the speed of light in a vacuum. So if you shoot a superfast electron into a pool of water, that electron is actually moving faster than the light waves it is creating. It is outrunning its own reflection. It is breaking the quote-unquote light barrier. And just like the jet creates a sonic boom, the electron creates a photonic boom. It is a shock wave of light. It is a cone of pure energy, and it glows. It glows a haunting electric blue. This is called Cherenkov radiation. It is the eerie blue light you see in pictures of nuclear reactors. That blue glow is the optical equivalent of a sonic boom. It is the scream of light trying to catch up to a particle that is too fast for it. So yes, you can outrun light, but only if you slow the light down first. You can beat it at its own game if you change the rules. But here is the final philosophical twist. Because light takes time to travel, and because shadows are instantaneous, you are never actually seeing the present. You are always living in the past. The only thing that exists in the now is the dark. Let's break your brain one last time. Look at your hand. You see it, right? No, you don't. You see light bouncing off your hand. That light travels to your eye. It hits your retina. Your brain processes it. That takes time. About 0.000000001 seconds. It's fast, but it's not zero. This means you are always seeing your hand as it was a tiny fraction of a second ago. You are seeing the past. Look at the moon. You are seeing it as it was 1.3 seconds ago. Look at the sun. You are seeing it as it was 8 minutes ago. Look at the Andromeda Galaxy. You are seeing it as it was 2.5 million years ago. You are trapped in a bubble of now, but you can only see the then. Light is the messenger, and messengers take time. But what about darkness? What about the absence of light? If the sun disappeared right now, snapped out of existence, the darkness at the source would be instant. The information, the lack of photons, would travel at the speed of light to reach us. We would still see the sun for 8 minutes, but the event itself, the vanishing, has already happened. The darkness exists there immediately. So, in a strange way, darkness is the only thing that is truly current. Light is always late. Light is always playing catch-up. Light is the history book of the universe. It tells us what happened. Darkness is the blank page where the future is written. When you look into the night sky, you see stars, but the vast black emptiness between them, that is the real universe. That is the majority. That is the darkness. And that darkness is expanding faster than we can ever hope to see. It is outrunning us. It is outrunning our telescopes. It is outrunning our understanding. So when someone asks you, what is faster than light? You can tell them, nothing. And you mean it literally. Nothingness is faster. The void, the shadow, the ignorance. The lack of a signal travels instantaneously. Because the lack of a signal is not a thing, it is a state. And states don't have speed limits. So we started with a shadow, a simple flick of the wrist. We ended up at the edge of the universe, watching galaxies disappear into the black. We learned that shadows can sweep across worlds faster than light. We learned that laser dots can break the speed limit. We learned that space itself expands faster than photons can swim. But remember the one thing that connects all of this. It's not the light. It's not the shadow. It's the idea. The concept of darkness traveling faster than light is a trick of the mind. It's a definition. It's geometry. But that trick reveals the deepest truth of physics. The universe has rules for stuff. It has speed limits for energy, for mass, for information. But for nothing? For emptiness? For the gaps between the stars? There are no rules. Darkness is the canvas. Light is just the slow, struggling paint. Next time you see your shadow on the ground, remember, you are looking at something that can break the laws of physics, if you just know how to look at it right. The universe is fast, but the dark is faster. If you want to keep breaking your brain with physics, click here to see why gravity isn't actually a force. It's even weirder than this. I'll see you in the next one.